Hi, I'm Chagai Rossman. I'll be presenting PyMSM, multi-state modeling in Python. This is joint work with Aya Keshet from the Weizmann Institute of Science and Professor Malka Gorfein from Tel Aviv University. Multi-state data are very common. They could be used to describe trajectories in many different health applications, from disease progression, such as in cancer, a participant's trajectory throughout the night, or a patient's trajectory throughout different hospitalization states, such as we had in COVID, mild, moderate, severe, and so on. Many different applications for these kind of data. So when a researcher or clinician is faced with these kind of data, she or he will probably want to characterize the possible transitions between states, occurrence probabilities, and of course predict the future paths of future patients. All of these are important questions which should be answered using proper multi-state modeling. So what we do in this package, we give the user ability to fit a multi-state model together, jointly learn the hazard functions for all the transitions using training data. And this is a bit tricky, but we have to take into account both static and time varying covariates, right censoring, competing events, which is very important in this setting, recurrent events, as we can go back and forth between different states, and left truncation. Once we do that and we have a fitted model from the training data, we can run Monte Carlo simulations for all of the patients or for one patient and take all the paths that are emitted by the model and return various statistics and plots, of course. This is all packaged up in a new Python package, which is easily installable. Pip install PyMSM. You can see the link above. We made an effort to make some nice docs, which kind of show all the capabilities and many full examples. The code is very simple. This is a few lines of code where you can load the data, instantiate a multi-state model, fit the model, and then run Monte Carlo simulations for one patient. Once you run those simulations, you get counts of different trajectories, as you can see in the slide here. And from these, of course, you can extract many meaningful statistics and plots, both at the individual level, but also on the population level, as we did in the COVID crisis, run simulations for many different groups of patients with different covariates and also different entry times, and look at hospitalization, utilization, and occupancy of different states. The package is also very modular. It's compatible for different time to event models, not just the Cox proportional hazard model, but survival forests and other custom models which you can provide. And this work had some published work already, both on resource utilization and hospital load, and increased mortality here in Israel with a prior R package, and now it's packaged nicely in Python for the community. That's it. We hope this will be of use to many researchers and clinicians. Please visit the link and learn more. Thank you very much for listening.